Welcome to the solutions of workshop 9.1. I suggest that you pause the video and try to answer the 5 questions. I've got 3 of them here, so pause the video and try to answer these 3, and then try to answer these ones as well. So advance the video a bit lower, further, and try to answer these. So we're going to go over these 5 solutions right now. So if you need more time, more explanation on how to do these steps, go back into prior videos where I actually do the lesson, but I'm just going to go over how to do the solutions right now. So in the first question, we have calcium hydroxide plus 2 hydrogen bromides producing calcium bromide and water. That was what our equation for the first problem was. And the first problem says that we have 3.21 moles of hydrogen of 3.21 moles of calcium hydroxide, and it asks us how many moles of water would be produced. So how many moles of water would be produced? Okay, that's the formula. That's our setup. To solve it, we're going to take what we know, 3.21 moles of calcium hydroxide times, for every 1 mole of calcium hydroxide, there is 2 moles of water. That's the stoichiometric relationship between the two. So to solve this, we're going to take 3.21 times 2 equals 6.42 moles of H2O. Calcium hydroxide cancels with calcium hydroxide. This is number 1, by the way. Okay, so that is what I got for number 1. Let's try number 2. Number 2, it says how many moles of aluminum sulfide are formed when you react 4.5 moles, get a different marker, 4.5 moles of hydrogen sulfide. You have to balance this equation first. All right, so let's try that one. So let's balance the equation. This is going to be number 2. Let's balance this equation. How many moles of aluminum sulfide are formed when you react okay, the equation's right below it, so we've got H2S plus aluminum hydroxide yields aluminum sulfide plus water. Okay, got that fitting in there. There we go. Okay, let's balance this. I have 1 aluminum here. I've got 2 aluminums over here, so I'm going to put a 2 in front of this. I got my aluminums balanced. Sulfur, I've got 3 sulfurs here, so I'm going to have to put a 3 in front of this one. So now I've got hydrogens. I've got 6 hydrogens here, and I've got 6 hydrogens here, so that would be 12 hydrogens. So if I put a 6 in front of this, that's 12 hydrogens, 6 oxygens, and I've got 6 oxygens. So this looks like it's balanced right here. It's kind of focusing in and out there. So we got this balanced. The question now says, how many moles of aluminum sulfide are formed when you react 4.5 moles of hydrogen sulfide? So 0.45 moles of hydrogen sulfide, and I want to know how many moles of aluminum sulfide. How many moles of this one am I going to solve for? So to do that, this is how I would do it. I would take 4.05 moles of hydrogen sulfide for every 3 moles of hydrogen sulfide. I'm going to get 2 moles. Oops, I was looking at this one. 1 mole of aluminum sulfide. For every 3 moles of hydrogen sulfide, the hydrogen sulfide cancels out. I have 1 mole of aluminum sulfide. So I'm going to take that number, divide by 3. So it is just 0.45 divided by 3. 0.15 moles of aluminum sulfide. That would be my answer to number 2 and the work needed to solve number 2. Okay, let's go on to number 3. Number 3, there is no equation here. It's part of the word problem. We have to figure out the equation by doing the word problem. So, how many moles of water and sodium nitride are formed when you react 0.75 moles of sodium hydroxide with ammonia? Okay, let's take a look at that. And a hint, ammonia would be the formula for hydrogen nitride. So let's take a look at this. To do this one, how many moles of water and sodium nitride are formed? That means that these guys are products. These guys are products. So for number 3, we know that these guys are products. When you react sodium hydroxide is NaOH. How do I know it's that? Because sodium is +1 and hydroxide is -1. So that's why it's NaOH. And NaOH is going to react with ammonia, which is hydrogen nitride. So hydrogen would be H positive and nitrogen is 3 negative. So hydrogen nitride would be H3N, but we call this ammonia. We rewrite it like this just for your information, NH3. That's ammonia, NH3. So plus ammonia yields how many moles of water? H2O. And sodium nitride. Sodium nitride would be sodium and nitrogen, sodium nitride. So there would be 3 sodiums per nitrogen. Okay, so this is our balanced equation. And it says we have 0.75 moles of sodium hydroxide. So 0.75 moles of sodium hydroxide. And I want to know both the amount of water and the amount of sodium nitride. Okay, so it's 2 things I need to answer here. So we'll just do do it twice. Sodium nitride, for every 1 mole of, sodium hydroxide, for every 1 mole of sodium hydroxide, we have, oh, this isn't balanced. So I don't know if that's 1 mole or not. No, it's not. So for 3 moles of sodium, 3 moles of sodium, nitrogen, I've got 1 here. I've got 3 oxygens, so I'm going to need to put a 3 here, 3 oxygens. So now let's take a look. Sodium is 3, 3. Oxygen is 3, 3. Nitrogen is 1, and I've got 1. Hydrogen is, I've got 6 here, and I've got 3 here, and another 3 here, 6. So now it's balanced. So for every 3 moles of sodium hydroxide, I've got 3 moles of water. Moles of sodium hydroxide cancel with each other, and also the 3's cancel with each other. So it's just moles of water. Just converts right in there. That's one of our answers. Our next answer, our next step will be just the same setup, but this time we're going to convert sodium hydroxide into sodium nitride. So again, 3 moles of sodium hydroxide per 1 mole of sodium nitride. So it would be 0.75 divided by 3, which would be 0.25. These guys cancel out with each other. 0.25 moles of sodium nitrite. Okay, that's the first 3. Okay, let's do number 4 now. Number 4, it says we are going to convert moles of titanium oxide into the mass of chlorine here. So let's take a look at setting that one up. So number 4, we're going to say we have, and this is already balanced for us, titanium oxide plus carbon plus 2 moles of chlorine produces titanium chloride and carbon dioxide. That's what's given here. The question says if we have 1.25 moles of titanium oxide, that's this one here, 1.25 moles of titanium oxide, we want to figure out what is the mass of chlorine that's going to be produced. So we're going to say how much chlorine is going to be produced in grams. All right, to set this up, this will take 2 steps. It's a little bit more complicated than the last one we did. We're going to say 1.25 moles of titanium oxide, and a mole to mole relationship is for every 1 mole of titanium. This is titanium 4 oxide, by the way. I'm saying that wrong. I apologize. 1 mole of titanium 4 oxide to 2 moles of chlorine. And so that's just simply 1.25 times 2, which is 2.5. So that's 2.5 moles of chlorine. But we're not done. We want grams of chlorine. So let's go 2.5 moles of chlorine. And we're going to multiply that by the molar mass of chlorine. So for every 1 mole of chlorine, the molar mass of chlorine, remember the periodic table, it's always grams per mole. So let's take a look at chlorine over here. Chlorine is 35.43. So it's 35.453. And chlorine, there's 2 chlorines, Cl2. So we're going to multiply that number by 2. And so the molar mass of chlorine is 70.906 grams per mole of chlorine. So we're going to take that number and multiply it by 2.5. And we get 177. And we have 3 significant figures in the question, so I'm just going to leave this 177 with 3 significant figures, grams of chlorine. That would be my answer to this one. So this one takes 2 steps. All right. All right, and now the 5th question, we have to write the balanced equation and then solve this one. So hopefully you pause the video and you've tried this one. Let's take a look at how to solve it now. So the question says sodium chloride is decomposed into its elements. So sodium chloride is decomposed into its elements. So number 5, sodium chloride is decomposed into its elements, which is sodium and chlorine. Remember, chlorine is a diatomic element. There's 2 chlorines for every 1 sodium. And to balance this, I'm going to put a 2 here to balance the chlorines, and then I'm going to put a 2 here to balance the sodium. So this will be the balanced equation for this. And I'm starting with 2.50 moles of sodium chloride. And I want to know how many grams of chlorine gas is going to be produced. So I want to know chlorine in grams. That's what I'm doing on this question here. So we're going to say 2.50 moles of sodium chloride for every 2 moles of sodium chloride. We have 1 mole of chlorine. but I want it to be in grams of chlorine, so let's just go this one step again. And remember, chlorine was 35.453 grams per mole. Chlorine is 35.453 grams per mole, so that's where I put this number here. And I'm going to multiply it by 2 because chlorine is Cl2. And so I've got this number again. We're going to say for every 1 mole of chlorine gas, we have 70.906 grams. Moles of chlorine cancels with moles of sodium chloride, cancel with moles of sodium chloride. Moles of chlorine cancel with moles of chlorine. And so to answer this question, we would take 2.5 divided by 2 times 70.906. And so my answer to this question is, with 3 significant figures, I would record it as 88.6 grams, and this is again of chlorine. 88.6 grams of chlorine. And that is workshop 9.1. I hope I got them right. I'm sure you'll tell me if I made any mistakes, but I just did it on the fly here. So hopefully there's not going to be any edits or revisions needed to this. And let me know if you got something different. Let me know if I did something wrong so I can fix this. All right? Take care. See you soon.